Hi there. So we were working on completing the square. That's where we left off in class. So I wanted to just do a couple more examples to refresh your memory. So let's look at if you have y equals x squared plus 6x plus 3 and we want to graph this. So in order to graph a parabola, so as soon as you see that this is a quadratic square, the highest degree is a 2, that's a quadratic equation, the graph is going to be a parabola. And so we talked about how if you have ax squared plus bx plus c, if a is positive, greater than 0 means positive, then you have a happy face parabola, so it opens upwards. If the coefficient of the x squared, the a, is negative, less than 0, then you have a sad face parabola, so it opens downward. So that's how the a in the front can help you decide what kind of shape you're going to have. So here we have the invisible 1, so it's a positive, so this is going to be a happy face parabola, so it's going to open upwards. And we need to figure out the vertex, and that's where completing the square comes in, because I know that if a function, a quadratic, looks like x minus h quantity squared plus k, the vertex is going to be hk, right? The opposite of whatever's in there, and that one stays the same. So if I had something like y equals 3x minus 1 squared plus 5, the vertex will be at 1, 5. The opposite of that, and that one stays the same. If I had y equals minus 2x plus 3 squared plus 1, say, now the vertex will be the opposite of, that's a plus 3, so the opposite of plus 3 is negative 3, and that one stays the same, so it will be a 1. Notice that the first one, the a, is positive, so this is going to be a happy face parabola, opens upwards, and here the a is a minus 2, so it's going to be a sad face parabola, so it's going to open downwards with that vertex. So our goal in completing the square is to make something like this, something that has the ax squared plus bx plus c form, look like that. So to complete the square, we're going to say x squared plus 6x plus, and I'm going to need to add something to complete the square, and then subtract it, plus 3. So the question is, what goes there? What do I need to add to this to complete the square? So completing the square, you take the coefficient of the x term, the linear term, the 1 raised to the power of 1. So I'm going to take 6 and I'm going to divide it by 2. 6 divided by 2 is 3, and then I'm going to take that 3 and square it. 3 squared is 9. So that's what I'm going to add. But if I just add 9 to this, I've completely changed the problem. So I'm going to add 9, but I'm also going to subtract 9. Notice that 9 minus 9 is 0, which means I'm adding 0 to this, so I haven't changed its value. But the reason I do this is because now I want to focus on these first 3 terms, and I want to refactor, or factor, I guess. It wasn't factored to begin with, so we're just gonna factor. And so I'm gonna have y equals, what two numbers are multiplied to positive 3 and add up to 6? Well, it's 3 and 3, so this is gonna be x plus 3 squared, right? But that's just those 3 first terms, so I have minus 9 plus 3, and minus 9 plus 3 is negative 6, so I'm gonna have minus 6. And now, by completing the square, I have successfully turned this a squared plus bx plus c into this format. And so now I can tell the vertex. So the vertex, in this case, is going to be the opposite of that, so minus 3, and that one stays the same, so minus 6. So when I go graph it, I'm going to go x is minus 3 and y is minus 6. So I'm going to go minus 3, minus 6, so somewhere over here. And now what kind of parabola is this? Is it going to open upwards or is it going to open downwards? And again, I look at that by the coefficient in the front. This is a positive one. So if it's positive, it's a happy face. So it's going to open upwards. To be more accurate, I would want to know what the y-intercept is. And in this format, the y-intercept is when x is 0. So if you put 0 there and 0 there, that x squared goes away, the 6x goes away, right? 0 squared is 0, plus 6 times 0 is 0, so I'm left with 3. So my y-intercept is going to be positive 3. So back on my graph, I'm going to go to, we were down here on minus 6, so I'm going to go 1, 2, 3. So that's the y-intercept. And it's a happy face parabola, so it has this increasing motion, so as best as you can draw it. If I had graph paper, this would be better. So I wanted to cross there, and then parabolas are symmetric, so that means that this is the line of symmetry, minus 3. So if you were to fold along that line, they should match up. So I'm gonna, as best as I can, try to draw it symmetric. And this is the vertex, minus 3, minus 6. So always label the y-intercept and the vertex. Sometimes you can go and label a third point in the parabola, and I usually just go for the mirror image. So to get from minus 3 to there, that's 0. So that was 3 points. So I'm going to go 3 points the other way. So 1, 2, 3. So that would be minus 6. So this will be minus 6 and up 3. And that's my parabola. So let's try another example of just simply completing the square without graphing it. And I'll do one that requires a fraction just to give you more practice with the difficult ones. So if I have y equals, say, x squared minus 5x plus 2. Right, if I want to find the vertex of this, there is a shortcut, and I showed you guys last time. The shortcut is the vertex is the x-coordinate. I usually denote it like that. V sub x for the x-coordinate of the vertex is minus b over 2a for ax squared plus bx plus c. So we'll do it first by completing the square, and then I'll show you how you can use that to get the same thing. So completing the square, I'm going to say y equals x squared minus 5x. I need to add something, and then I'm going to need to subtract the same thing, and then plus 2. So what do I need to add and subtract? Well, we're going to go over here. I'm going to take the minus 5, take the sign with you. Minus 5 divided by 2. That doesn't really give me much. I don't want to turn it into a decimal, so I'm going to write it as negative 5 halves. And then the process of completing the square is you square it. Right, complete the square, you have to add a square to it. So I get positive 25 over 4. So that's why we add and subtract. Again, I add and subtract it because that gives me 0, which means I'm not changing the value of the problem. Right, think of it in terms of real life stuff. If you have $5 and I give you $0, you still have $5. But if you have $5 and I give you $2, then you have $7. I've changed what you had. So we don't want to change the value. So when I add something, I want to subtract it again. So now we go to focus on the first three terms, and so we're gonna go over here. So I'm gonna have y equals x squared minus 5x plus 25 over 4, and then, well, I guess I could have factored it. So I'm going to have negative 25 fourths plus 2. I'm going to write as 2 over 1 because I need a common denominator. Now this factors into a perfect square. Which perfect square? 8 minus 5 halves. Two numbers that multiply to 25 fourths and add up to minus 5. And you might be thinking, what? How did you get that so fast? The trick is, whatever you get when you divide by 2, that's usually what goes in there. So it's really nice. When you divide by 2, that's what's going to go inside the parentheses. And now get a common denominator. Common denominator is 4, so I'm going to multiply top and bottom by 4. So I have 8. So negative 25 plus 8, so what's that? Negative 17 over 4. So the vertex is the opposite of what's in the parentheses, so 5 halves. It's really whatever makes the inside 0. So if you set x minus 5 halves equal to 0 and solve for x, you'll get 5 halves. So it's a horizontal shift as we talked about last time, and this one stays the same. So minus 17 over 4. Cool. So now using this handy little formula, we'll do the parallel over here. So I have y equals x squared minus 5x plus 2. So if I say the x value of the vertex is minus b over 2a, I have to know what b is and what a is. So in this particular case, right, a is 1, b is negative 5, and c is 2. C is your y-intercept. So that's good to know when you're graphing. But for the vertex, I need b and I need a. So the x-squared on the vertex is negative b, so minus a minus 5 over 2a, 2 times 1. So minus a minus is positive, so I get positive 5 over 2 times 1 is 2, which notice that's what we had here. So this is a shorter way of doing it. How do you find the y value? Plug it back in. So the y value of the vertex is plug 5 halves in for x in the equation x squared minus 5x plus 2. So after you do that, you should get the same y value. Alright, so I hope that helps with some of the completing the square problems that you might encounter in homework, but you can also use the shortcut method.